Hello, dear students. So, today we are going to learn about energy. We all know very much about energy. In this video, we are going to cover basically three topics. First one, energy. In this, we are going to discuss different forms. What are forms that we know around us that we used to see, and interconversion of energy and conservation of energy. These are the three important topics that we are going to cover in this video. So let's begin. Energy, the common definition that you have studied in your previous classes, like it is the capacity to do work. That means we need energy to do some work. How much amount of energy do we have? On the basis of that energy, we can do the work. Now, when force is applied on a body and the body moves, then work is said to be done. And for doing this work, energy is required. That means to do something, to apply force on something for doing work, let's take an example that we need or we want to push a table or move a table from somewhere or to bring a chair from somewhere. We need to apply force. So when we apply force to do some work, we need some energy in our body. During this, transfer of energy takes place from one body to another body during the happening of work, which means while doing something like our muscle force or power or energy we use to push a table. So we are using our muscular energy to push the table or to move the table. So in that case, what we are doing, we are transferring our energy to the table. So the table moves just because we have applied of energy, our energy, that is muscular energy, on the table. So the table gains a speed or work has to be done on the table. So that energy from our body transmitted to the table. Now, for doing work, energy is required, which means energy is spent on doing some work or action. For doing some action or work, energy is spent on it. Now, next is work energy relationship. Now, you must know there is a relation between work and energy. They are relative terms, work and energy. Like we need energy to do work, and to do more work, we need more energy. Just take an example like you are having a mobile phone which is charged 100% or it lasts for 24 hours. Just an example. So, suppose your battery is 50% charged or remaining charged is 50%. So, how long your mobile phone will go? Correct. It will go for 12 hours. So, like that, the amount of energy in your body, the same amount of work you can do, not more than that. Less you can do, but not more than that. So, like that, work and energy is related to each other. Now, for measuring energy, we need a unit. So, James Watt was a scientist, or that Joule was a scientist who has given a unit, that is joule, and energy is measured in the same unit as work. As we know, work is measured in terms of joule, that much joule work is done in that way. Energy, all kind of energy is measured in terms of joule, and 1 calorie is equals to 4.186 or approximately 4.2 joule. Calorie is one another unit which is commonly used. Like, we used to measure our energy of food that we eat on the basis of calories. That means how much energy we will get from that particular food item. It is mentioned in terms of calorie. So actually that calorie defines how much energy we will get from that particular food. Now, different forms of energy: mechanical energy, heat energy, light energy, chemical, sound, magnetic, electrical, and nuclear energy. Let's talk about a little way for mechanical energy. Just take an example of spring. When you compress a spring, we store some energy in it, and as it is a spring, we call it mechanical energy. When we compress it, its size changed, so we call it configuration. Configuration means shape and size or dimensions, you can say. So when we compress a spring, the energy gets stored in that spring. When we release it, it do some work. It will do some work. So we call it mechanical energy. Another example, like windmill. We all know windmill converts the wind energy into kinetic energy, as wind is the blowing air or moving air. So the moving air consists of kinetic energy, and that kinetic energy is used to rotate the turbines of this windmill. Then this energy is converted into some other form of energy. So this energy is known as mechanical energy. Later we will discuss over conversion or interconversion of energy in this video. Heat energy, we all know heat energy. Burning fuel gives us heat. Even when we glow light bulbs, electrical energy gives some power as heat. Light energy, the light rays coming from the sun is consisting that energy. So that energy as light energy taken from the plants or taken by the plants for converting it or to make their food during the photosynthesis. Chemical energy. Chemical energy, the chemicals present in that battery can convert into electrical energy. So whatever matter present on earth, it consists of some energy. That energy which is stored in the matter is known as chemical energy. Like whatever food that we are eating, it stores energy. It is stored energy in the form of chemicals like fat, vitamins, minerals, whatever. They all are chemicals. So we are getting the energy out of it. So that energy which is stored in the matter is known as chemical energy. Sound energy, these devices you have seen, you all are having it at your home. So this devices produces sound. So sound is a form of energy. And why we used to call sound as energy? Because even a sound can do work. You can see these devices which produces sound. The membrane of these devices vibrates. So vibrating membrane means vibration means motion. So motion means kinetic energy. That's why sound is also considered as kinetic energy. Electrical energy, these are the lightning, thunder, So these are the energy which is used to run our devices. We all know it is the flow of electrons. You all know electrons. It is present in the atom. So that electrons, when they are moving through wires and cables, they are called electrical energy. They use to run television, to charge our mobile phone, and many things. All the devices that we are having at our home is run with the help of electrical energy. Now this is a huge magnet. So this magnet is having a force. It can do some work, like it can lift something like made up of iron. So it can do work, and as it is magnet, we call it magnetic energy. Basically, in this diagram or in this picture, what you see is actually an electromagnet which is run with the help of electrical energy. So electrical energy is basically converted into magnetic energy in this case, remember that. But ultimately we are using a magnet in this case to lift the iron matter. That's why we call it magnetic energy. And this is the picture of nuclear power plant. Nuclear power plant use nuclear energy to convert water into steam, and that steam is used to run the generators which produces electricity. And nuclear energy is what? Nuclear energy, inside an atom there is a nucleus. So that nucleus is holding tremendous amount of energy. That energy, when we break this nucleus, we get lots of energy in the form of heat. Atom bombs, these are based on this nuclear energy. The energy stored in the nucleus of an atom is known as nuclear energy. So when this energy comes out in the form of light or tremendous amount of heat, we use this energy to produce electricity. Now let's see what you know up to this. You have to answer these questions at the comment section. Pause the video, write the answer in the comment section, then again proceed with the video. Now coming to the interconversion of energy. Conversion, you know. Conversion means to convert. Inter, in between one form to another form. So the conversion of energy from one form to another form is called interconversion of or transformation of energy. Here in this diagram, you can see when we compress the energy, it stores energy in the form of potential energy. When we release, the ball start moving, it gets converted into kinetic energy. This all comes in mechanical energy. So basically mechanical energy is the combination, or you can say is consist of two kinds of energy, that is potential and kinetic. So when the body is at certain height, it will possess potential energy, and if the body is in the motion, it will have kinetic energy. Once again, let's see. Mechanical energy is consist of two things: potential and kinetic. So potential means position, configuration means shape or size of the body changes and certain amount of energy released or maybe stored in that body, then we call it potential energy. When the body is in motion, if it is moving, it will possess kinetic energy. So just remember that potential related to position, that means at height or change in shape, like spring is compressed in this case, so this will have a potential energy. And kinetic, when the body is in motion, it will have kinetic energy. So just you have to remember this, that position means potential, kinetic means motion. Potential energy requires height, or it is based on height. If the body is at certain height, it will possess potential energy. More the height, more potential energy. More the speed, more kinetic energy. Both the energies are proportional to masses. If more mass, more energy. You need to learn this thing. Potential means position or configuration, shape or size. If the shape and size of a body changes, it will possess potential energy. Kinetic, in case kinetic means motion. So motion relates with kinetic energy. So hope you have understood this. Now next, another example, when we lift up a hammer, as we are lifting up the hammer, that we are increasing its height. So at that position, the hammer is having potential energy. That potential energy, when we move the hammer from height to hit the nail, it converts into kinetic energy. So potential to kinetic energy. Again, in this bow and arrow case, when we stretch this string, that means we are changing its position or size. So at that time, the energy gets stored in the bow in the form of potential energy. When we release this arrow starts moving. So that arrow will have the kinetic energy as it came in motion. So potential to kinetic energy. Now coming to the conservation of energy. What do you mean by conservation? To save, to keep safe or safe. So the energy is always safe or it doesn't change. So energy can neither be created nor destroyed. It can only be changed from one form to another. Like electricity is converted into light energy with the help of a electric bulb. But remember one thing, what we get from the bulb, correct, we get light from the bulb. But during the conversion, we get heat or some heat out of that bulb, which is not required by us. So that heat which is produced from the bulb, which is not required, we call it unuseful energy. And the useful energy is what? The light that we need from the bulb. So electrical energy is converted into two forms. One is light, that is useful energy, and another is heat, which is unuseful. So that unuseful light or heat which is coming out from the bulb is known as dissipated energy. That dissipated energy plus useful energy is always equal to the amount of electrical energy. That's why energy doesn't change. It only changes from one form to another form. It doesn't destroy or we can't create it. Here in this diagram also you can see at a particular height this boy on a roller coaster is having maximum potential energy. Maximum potential energy. So that potential energy is converted into kinetic energy. Then this kinetic energy again converts into potential energy. So this potential energy gets converted into kinetic energy, that kinetic energy again converted into potential energy. So like that, the total remains the same. The total amount of energy remains the same. Hydropower plant, you all know about it. In hydropower plant, water energy or flowing water energy is converted into electrical energy, or we produce electricity with the help of flowing water, that we all know. Here, this is a water reservoir. So in this water reservoir, tremendous amount of water is stored, and when we release this water, it is stored. So this water is having potential energy. This potential energy we use to make it flow. So this flowing water is having kinetic energy. So this potential energy converts into kinetic energy, which is further used by this turbine. It will start rotating now. When we allow this water to flow over this turbine, it will start rotating. So this rotating device is connected to the generator, which will produce electricity. So like that, in hydropower plants, stored water which is having potential energy, that potential energy is converted into kinetic energy with the flowing water, and that flowing water runs the turbine connected to the generator, produces electricity. So like that, conversion of energy is taking place and the energy remains constant or unchanged. Potential is converted into kinetic energy. Similarly, in case of pendulum. Now you all know pendulum. Pendulum, a ball or a metal ball is connected with a lightweight string. Then it oscillates like that. So at the maximum position, it will have what? Potential energy. Correct. So this potential energy gets converted into kinetic energy. In this case, this bob will have maximum kinetic energy, and that kinetic energy has come from this potential energy. So potential energy converted into kinetic energy, then again it converts into potential energy at its maximum height. Now next, again check yourself. State the energy conversion in the following: solar cell, you all know solar cell, windmill, and car engine. Answer in the comment section. Just pause the video for a while, write your comment in the comment section, then move ahead. Thanks for watching. Hope you have understood energy in a simple way. Write your comments and subscribe my channel. Thank you.